Rundown of radiation, the concept of radiation. So when we say radiation, there are actually all types of radiation. It's an energy that has a very high frequency, but typically when we're talking about radiation, we're kind of referring to nuclear radiation. Technically, UV, ultraviolet radiation, is a type of radiation. But when we say radiation, we're typically referring to nuclear radiation, which is from the nucleus. And the nucleus is protons and neutrons. Now, the nucleus is the densest area of existence anywhere in the universe other than a black hole. Most of an atom is space. You have a very dense nucleus, and then you have a large amount of space where electrons move around. You and I are mostly space. So nucleus, you have particles or energy that are emitted from the nucleus, and this occurs naturally. It's all around us. Why do they emit particles from the nucleus? Well, there are different isotopes of an element. All elements have isotopes. Atoms that have a different number of neutrons, not different neutrons, different number of neutrons. So carbon has 3 isotopes. You could write the name of the isotope like that. You could write the name of the isotope like that. That could be a 12. You could write the name of the isotope like that. But that is the mass number, the 12, the 13, or the 14 protons and neutrons. And so since every carbon atom has 6 protons, some carbon atoms have 6 neutrons, some 7 neutrons, some 8 neutrons. Carbon 14 happens to be radioactive. So when you have a nuclear reaction, radioactive atom, they are unstable. Something about the nucleus is unstable. It's usually the ratio of protons and neutrons, and so it will change. Now this represents a nuclear equation. So the arrow means to change. There are 3 types of nuclear radiation. You don't have to know them. You can think of them as just being different sizes. And so if carbon 14 undergoes this type of radiation, it creates a new element. If it undergoes this type of radiation, it creates a new element. If it undergoes gamma radiation, gamma is just a little piece of energy. It would still be carbon 14, but gamma radiation is a type of nuclear radiation. We don't actually know when a specific atom will actually undergo radiation. We do know when half of a sample will actually change from one element to another element, one half of a sample. So that's called the half-life. So whatever the half-life is, it's constant. Half would undergo a change, and then eventually it gets down to an amount that's not necessarily dangerous. And we use half-life calculations in lots of different things. We're not going to go into that right now. The half-life for a nuclear atom, a radioactive atom, or an element, it could be anywhere from seconds to millions of years. Depends on the element. So that's a little bit about radiation. Now, it can cause cancer depending on how much and long you're exposed to. So when we think of radiation, we often say, well, it can cause cancer, but it rarely does. Chemicals, your behavior, smoking, drinking, your genetics, all of these are greater causes of cancer. So it's very rare to be exposed to a concentrated amount of radiation. So really, it statistically really doesn't cause cancer relative to all of the other things that can cause cancer. There have been very few times when people have been exposed to large amounts of radiation. Obviously, the 2 times that atomic weapons were used in war, World War II, the United States against Japan. Outside of that, Chernobyl and Fukushima, These are the scale ratings. The International Atomic Energy Commission has a scale from 0 to 7 of nuclear accidents. There have been 2 that were number 7, 1 that was a number 6. And so these were things that caused a lot of radiation to be exposed to the environment. A lot of people who died at Chernobyl died from radiation poisoning. They didn't die from cancer. If you get exposed to a large amount, it's like a poison, and it damages cells and organs, and you are usually killed within a matter of days or weeks if there's a large enough amount. So that's not cancer. Radiation is not used for electricity. We do not use it to produce power. We use it a little bit, in some very small battery-like devices that we might put in a space probe or something, but for the most part, it's okay to say that we do not use it for electricity at all. We can use it to treat cancer. It can damage cells, which means that it can damage bad cells. A nuclear med tech career that specializes in helping treat cancer patients with radiation. We can also use it to take images. We can use actual nuclear radiation to take images. X-rays are not nuclear radiation. They are ionizing radiation. They are a type of ionizing radiation. And X-rays are not nuclear radiation. But you can kind of think of it as the same. It's all the same. We can use it to take images to help diagnose what's going on. We do use radiation to kill bacteria on food a little bit. Do use it in smoke detectors. A very interesting person, Marie Curie. She's the scientist whose picture's on my wall. She did a lot of work with radiation early on, didn't discover it, but sort of helped discover the fact that a lot of atoms are radioactive and they actively give off particles. And she was married to another famous scientist. She's the first woman to win a Nobel Prize in a scientific field, physics or chemistry or medicine. She's the first person to win 2 Nobel Prizes, and she's the first person to win a Nobel Prize in 2 different fields. She won a Nobel Prize in physics, and she won a Nobel Prize in chemistry. Has a very interesting professional life as a scientist, has a very interesting private life. So Marie Curie has an element named after her, and we also use Curie is a unit of radioactivity that's also been created in her honor. So that is radiation.